Yeah, hope my this whiteboard is visible now.
Yes, sir.
Yeah, thank you. So, is it possible to say what we have discussed in the last class? Any one of you? Though I am displaying, yes, I wanted to hear from your side.
Sir, we started with Hilbert Transform and we studied magnitude response and phase response.
Okay. Yeah. So, is it possible to say what is Hilbert transform?
It is
Yes,
a
any others?
phase shifter, sir. Quadrature phase shifter. It shifts positive frequency by negative 90 degrees and negative
No,
frequencies by positive.
no,
I
man.
know the concept of negative and positive frequencies do not exist, but that's what
Uh,
it means.
no, positive frequencies exist, no.
I mean, negative frequencies do not
Yeah,
exist.
negative frequency does not exist. It is just for mathematical representation. Because as I said, cos theta is equal to what? E power j theta plus e power minus j theta by 2, right? So if you want to express in terms of exponential form, both positive and negative things will be there as a pair. Okay, so yeah, any other student? What Prajwal is said, people can add now. I think something is said different. It
Sir,
provides.
it suppresses the signal based on phase selectivity.
Suppresses or separates.
Separate, sorry.
Yeah, separation of signal. Okay, I said can be done in two ways. One is by using frequency selectivity, right? That will be done by using Fourier transform, and another way of separating the signal by using phase selectivity. So that is done by using Hilbert transform. So basically, Hilbert transform provides phase shift, right, for the entire signal, right? So it provides minus pi by 2 radians for positive frequencies of the signal. Okay, so mathematically we express the Hilbert transform of a signal as g cap of t or g hat of t, which is equal to g of t convolved with impulse response of the Hilbert transform, right? So in the last class, I think just I will scroll out. So yeah, I said this is the Fourier transform of the impulse response of the Hilbert transform, which is equal to minus j sin m of f, right? So I started defining what is sin m function, right? Then we have discussed the Fourier transform of the impulse response. It is basically a complex quantity, right? So as one of your friends said, we have discussed the magnitude response. See, only means when we pass a signal through a Hilbert transform, the magnitude of the signal is not getting affected. Okay, it is constant for all frequencies. Only the phase of the signal will be changing. Okay, so the phase will be changing by what? Minus 90 degree for positive frequencies and plus 90 degree for negative frequencies, right? So as some of you said, it is known as phase shifter or quadrature filter. Okay, so I think we were discussing this. Yeah, I told what is the impulse response of the Hilbert transform in time domain, which is equal to 1 by pi t, and its Fourier transform will be what? Minus j sin m of f. I think I asked you people to find out. I think I am doing that only, right? I only started deriving that. How do we get that one? So I started with this equation, g cap of f is equal to, means I said in time domain, we write g hat of t is equal to g of t converted with impulse response of the Hilbert transform. In frequency domain, it will be what? Multiplication of their Fourier transform. So with respect to that, I wrote g cap of f is equal to g of f into hst of f, right? So I have written very clearly here. So this is the frequency domain representation of the Hilbert transform and the multiplication in the frequency domain, right? I said to find the impulse response of the Hilbert transform, we are using the derivative properties of the Fourier transform. So I was doing that, right? So I said x of t, its Fourier transform to x of f, then d by dt of x of t will be j 2 pi f into x of f. So I took my x of t as sinum function. So I found what is the derivative of this. So I think till this we have discussed in the last class, right? Right?
Yes, sir.
So we'll continue further. Hope you are all with me. Or if you have any issues, difficulties, you can always express. If you do not have any doubts or questions, I will go further. Yes, shall I go ahead?
Yes, sir.
Thank you. Okay, I think this point is clear. No? How do we take the derivative, right? We all know derivative of a constant is 0. So with respect to that, I wrote for both positive side and negative side. And I said at t equal to 0, there is a step change in magnitude, right, which is equal to 2. So when I take the derivative of that, I can write d by dt of sin of t is equal to 2 into del of t at t equal to 0. Right? Okay, so the next step is okay. So what I can write is therefore I can write d by dt, right? D by dt sinum of t, d by dt sinum of t will be equal to what? I said it is 2 into del of t. Okay. So if I take the Fourier transform of this, so what I can write? Fourier transform of this, that is d by dt of sinum of t, okay, which is equal to Fourier transform of this one, right? 2 into del of t. So which is equal to what I can write? So 2 is constant, I can take it outside. Then I can say what is the Fourier transform of del of t. So anyone can say what is the Fourier transform of del of t? Yes, quickly. What is the Fourier transform of del of t? Yes? I expect these simple answers. Fourier transform of an impulse function. Yes, no idea. These are very basic things. Fourier transform of del of t will be equal to 1. Okay. So I can write it as 2. 2 into 1 is 2, right? So hope noted, na? Yes, is it noted? Shall I move up?
Yes, sir.
No.
Yes, sir.
So from derivative property, I can say from derivative property of Fourier transform, right? From derivative property of the Fourier transform, what I said, the Fourier transform of d by dt, right, of sin m of t, right, will be equal to, that is d by dt of x of t. My x of t is sin m of t, right, which is equal to what? J 2 pi f into x of f, right? So that x of f is what? Fourier transform of f of t. Fourier transform of f of t, right? And we have understood which is equal to 2, right? We understood Fourier transform of d by dt of sin m of t is equal to what? 2. We have found just right above. So what I can say is I can write this. This implies what I can write is j 2 pi f, okay, into Fourier transform of sin m of t, right, which is equal to 2. Okay. So from this, I can write the Fourier transform of sin m of t. Fourier transform of sin m of t, which is equal to what I can write? 2 divided by j 2 pi f. J 2 pi f. Right? So 2 will get cancelled. I can write it as what? 1 by j pi f. 1 by j pi f. Okay, so that is the Fourier transform of sin m of t. Okay. Okay, I'm moving up. I hope people are also noting simultaneously as I write. So what I can say is I can write sin m of t. Okay, sin m of t. Okay, its Fourier transform will be what? 1 by j pi f. 1 by j pi f. Okay. I can put this in the box so that you will understand. Okay, sin m function, its Fourier transform will be 1 by j pi f. So now let me use the duality property of the Fourier transform. You know what is duality property? Anybody can say? Yes? Duality property. Is nobody aware? Let us now use duality property. Yes, are you aware of this rule or not? Duality property. Have you heard about this duality property? Duality property of Fourier transform. So what I wanted to say is duality property. See, I know what is x of t, right? X of t, its Fourier transform will be what? I say x of f, right? So if I write capital X of t, okay, sorry. Okay, so capital X of t, right, can be, it's based on duality property, I can write x of small x of capital F. Yes, sir. So this is the duality property we say. Okay. So using this property, using this property, I can apply this property to the above equation. Okay. So what I wanted to say is, using duality property. Yes, anybody can say what I can write. How do we apply this duality property to the above equation? That is what I have written as sin m of t is equal to 1 by j pi f. So I can write 1 by j pi t. Okay, 1 by j pi t will be written as sin m of minus f. Okay. So this is how I apply the duality property to the sin m function. So with this, I can write, so which is equal to, that is 1 by j pi t is nothing but sin m of minus f can be written as minus sin m of f. Minus sin m of f. So further, I think we will be able to arrive to that equation. What is the Hilbert transform in time domain, and what is its Fourier transform? Yes. So can I write that is 1 by j pi t is what? Minus sin m of f, right? So can I write 1 by pi t, right? 1 by pi t means I can take j's that side now, right? Will be what? Minus j sin m of f. Minus j sin m of f. Yes, is this clear? Yes, is this point is clear? Oh, sorry. Yeah.
Sir, can you repeat again?
Yeah, so what I said, I am using the duality property, right? So what I said, what is the duality property? X of t, its Fourier transform is x of f, right? So capital X of small t. So based on the duality property, I can write small x of minus f. Okay. So I am applying this to the above equation, that is sin m of t is what its Fourier transform will be 1 by j pi f, right? So I write using duality property, I can write 1 by j pi t, means I am replacing this f by small t, okay, is equal to sin m of minus f. So it is nothing but minus sin m of f. So what I did now, I moved this j to this side. So 1 by pi t, okay, 1 by pi t is equal to minus j sin m of f. That's all. Means, see 1 by pi t, its Fourier transform will be minus j sin m of f. Or what I can say is minus j sin m of f. Its inverse Fourier transform will be 1 by pi t. That is what the meaning is. Okay. Yes, is this clear? So what I can say is this point, this will be the impulse response of the Hilbert transform in time domain. So what I can say, HHT of t, HHT of t I can say, and this one will be what? This one will be Fourier transform of the impulse response of the Hilbert transform. So that I used to represent as what? HHT of f. Hope this thing is clear. Yes, is it clear?
Yes, sir.
So finally, what I wanted to say is the impulse response of the Hilbert transform. Okay, in time domain. What I wanted to write is equal to 1 by pi t. By pi t. So these are all very basic steps which I need not solve so much, but fine. At the beginning, I said you all should refresh your basics. Okay, this fine. So the impulse response of the Hilbert transform in time domain will be equal to 1 by pi t. Okay, in frequency domain, that is the Fourier transform of the impulse response of the Hilbert transform will be what? Minus j sin m of f. So that we have proved. Okay. So I can rewrite this in another form because what I said at the beginning with respect to the block diagram, right? Means by writing this block, right? I said input signal is g of t, input signal is g of t, and this is the Hilbert transform, right? And having an impulse response is ht of t. Okay, so output of this Hilbert transform will be what? I will be writing g cap of t, right? So which is equal to what? I said g of t is convolved with the impulse response of the Hilbert transform of the this one, right? Input signal is convolved with the impulse response of the Hilbert transform. So with respect to that, I can express this in terms of convolution integral also. Means the Hilbert transform of the signal can be expressed in terms of the uh, 1 minute. Yeah. Okay. So what I said, g at of t, that is the Hilbert transform of a signal g of t, na, will be equal to what? G of t, that is input signal, is convolved with the impulse response of the Hilbert transform, right? So I said I can express this in terms of convolution integral also. So you all know what is convolution integral? Means what I wanted to say is, so I said g at of t will be equal to g of t, right? Convert with what is the impulse response of the Hilbert transform? Just now I wrote it is 1 by pi t, right? 1 by pi t I can write it. Okay. So how do we express this in terms of convolution integral? Yes. See, convolution integral means what? I say integral from minus into infinity g of tau, right? G of tau into 1 by pi of t minus tau into d tau. Can I write like this or no? Yes? Convolution integral. I hope you are aware of this, right? So with respect to this, I can take 1 by pi as outside. Okay. 1 by pi I can take outside because it is constant. 1 by pi. Then what I can write? Integral from minus infinity to infinity g of tau, okay, into 1 by t minus tau, or I can say g of tau divided by right, g of tau, okay, so divided by t minus tau into d tau. T minus tau, t minus tau into d tau. So this is the definition of Hilbert transform, which you find in the textbook. When you open your textbook, you will get the first equation as this. So to understand, I have done all this background of mathematics. Okay. So I hope, I don't know how many of you have opened your textbook. Just go through the textbook, you will find. So the Hilbert transform of a signal g of t can be written as like this: g hat of t is equal to 1 by pi integral from minus to infinity g of tau divided by t minus tau into d tau. You get this as your first equation. So instead of writing directly this, I don't know how many of you would have understood clearly. At least now you have some hope that is okay, it can be written like this. Is it so? So you can call, I won't give a number, I'm just putting in a box. So this is your expression for Hilbert transform of a signal in convolution integral form. Okay. People should respond. Is it fine or do you have any difficulties? So before I take up the properties of this Hilbert transform, let me take up a simple example, okay, to find the Hilbert transform of a given signal. Then we'll see, or we'll try to understand the properties of the Hilbert transform. Okay. Yes, note down this problem. So this is about finding the Hilbert transform of a given signal. So determine what we are noting. Please note down this. Determine the Hilbert transform. Determine the Hilbert transform of rectangular pulse. Determine the Hilbert transform of rectangular pulse. So the rectangular pulse is defined as like this: RECT. Okay, we represent RECT of T. Rectangular pulse will be equal to 1 over the interval when T is less than half and greater than minus half. Okay, and it will be 0 otherwise. So this is the specification of the rectangular pulse given. So its magnitude will be 1 over the interval from minus 1 by 2 to plus 1 by 2. Okay, for other places its value is 0. So we need to find out the Hilbert transform of this rectangular pulse. So how do I represent this graphically? So this is told in the equation format. So I can represent this in graphical form like this. So this is a rectangular pulse, right? If I take this as time, and I can say this value. Okay. This as what? This will be 1 by 2 and this will be minus 1 by 2. And its value will be 1 over this range. So this is my rectangular pulse. RECT of T. Yes, try finding. Use your knowledge of mathematics. Use this, whatever the convolution integral I said, you can use that and you can find out. Hope noted now this. Yes, people should respond. Have you noted this?
Yes, sir.
Yes, sir.
Because if I want to see your face now, I need to switch my screen. Every time I need to again. If I now I think you'll not be able to see my whiteboard, no? Are you able to see my whiteboard?
Yes, sir.
Oh, you're able to see. Okay, then I need to switch and to see your faces. Okay. Yes, Rohit Joshi. Rohit Joshi. Say I can't call 10 times your names. Once I call, you should respond. Then I understand you are with me. Otherwise, simply logging in. That's all. What about Girish?
Sir.
Girish is there. Fine. Manjunath.
Sir.
Good. Are you understanding, man, what I'm saying?
Yes, sir.
Manoj?
Yes, sir.
Okay. Yes, Sneha.
So,
Oh, there. Okay. So you're able to follow what I'm saying. What's Sneha?
yes, sir. Yes, sir.
You have to work hard because it will be a little bit hard. You may be finding it is more of mathematics. Yes, at the beginning it is like that. Yeah, how do we proceed this then? Is it possible to try or you want me to show one? How to proceed? Yes, you write first equation. What is that equation? Hope you noted, no? If I move up, is fine, no? Yeah. So as I said, we can write what is that g hat of t. Anyone can say what is g hat of t? I can write. Of course, it can be told in different ways, but at least one simple equation. That is g hat of t. That is Hilbert transform of a signal g of t will be equal to what I can write. The input signal g of t, right, is convolved with the impulse response of the Hilbert transform. Okay. Just now I said it can be expressed in terms of convolution integral as what? Integral from minus infinity to infinity g of tau, right? G of tau into what? Time shifted version of the impulse response of the Hilbert transform, right? So which is nothing but what I can write HT of t minus tau into d tau. Okay, to d tau, right? So what is my g of tau? Here it is a rectangular pulse, right? My g of tau is a rectangular pulse. I can write integral from minus to infinity. So it is my rectangular pulse, RECT of, I think I can write this as tau, right? Into 1 by pi of t minus tau into d tau. Okay, so now I know this rectangular pulse exists over what interval? From minus 1 by 2 to plus 1 by 2, and its value is 1. So now I can change the limit and I can substitute its value. Okay, so I can write as what? So integral, so what will be its limits now? It will be from minus 1 by 2 to plus 1 by 2, isn't it? During that time, my rectangular pulse value is what? 1. Right? So 1 into the remaining terms I can write as it is. So 1 by pi of t minus tau into d tau. Is this fine? So now we need to clear this mathematical simplification role. So what we usually used to do is we let me say let this t minus tau. Okay, let t minus tau which is equal to x. I'm just simplifying. Okay, t minus tau I'm keeping it x. Then minus d tau will be equal to what? Dx. Minus d tau is equal to dx. So I can substitute this in the above equation. Okay. So if I do that, so what I can write? So I can write g at of t will be equal to, right, integral. So here it is what? T minus 1 by 2 to t plus 1 by 2. Okay, t plus 1 by 2 and 1 by, the 1 is there, 1 by pi minus x I can write, right? So t minus tau is x now. I can write 1 by pi x into what? D tau is minus dx. Right? Yes, is it fine?
Yes, sir.
So I think further simplification can be done from your side. You'll be able to do it. What you can do, you can take 1 by pi outside, right? Take minus 1 by pi outside, 1 by pi outside. Then you write remaining things, that is integral from what? T minus 1 by 2 to t plus 1 by 2, t plus 1 by 2. Then what? 1 by x into dx. 1 by x into dx. So you know what is the integral of 1 by x into dx? Yes, quickly, anyone of you can say?
Log mod x.
So minus 1 by pi, I can say ln x, right, with the limits t sorry, here some limits is there. So this is t plus 1 by 2 to t minus 1 by 2. It is, so it is minus. Okay, t plus 1 by 2 to t minus 1 by 2. Here also it is. So it is t plus 1 by 2 to t minus 1 by 2. So t minus 1 by 2. So what I can write here, t plus 1 by 2 to t minus 1 by 2. So I hope we'll be able to substitute no limits, right? Substitute limits and you can simplify and say what is the equation you can write. Yes, at least this you people should be able to tell, na? Substituting limits, that also I need not wait. Yes, what we can write? Minus 1 by pi. Minus 1 by pi. Then what?
ln of t minus 1 by 2 by t plus 1 by 2.
Yeah. ln of t minus 1 by 2. T minus 1 by 2. Right? Upper limit minus lower limit, right? Hope everybody is there with me. Is t plus 1 by 2. Yeah. Then what I can write? Is what I can write.
1 by pi into ln of t plus 1 by 2 by t minus 1 by 2.
Yeah. So that is log A minus log B, right? It is nothing but log of A by B. Yes or no? T minus 1 by 2, right, divided by t plus 1 by 2. So this is my g hat of t. My g hat of t.
So you can take the minus also inside the log.
Yeah, you can do that. I kept outside only. Yeah, you can express in that way also. So, yeah. Yes, is it fine or do you have any difficulties? Hope everybody noted these steps. See, these are all very simple mathematics only, no? So nothing new or something I am deriving which is not known by you people, right? So basic things only. So what I said, I wrote the formula of Hilbert transform, right? The convolution integral. Then I just substitute the value of this rectangular pulse with these limits, right? Then I made some simplification by letting t minus tau is equal to x, and you know what is this d tau will be equal to dx, right? So substitute this means I bring it to this form. It becomes easy for me to integrate. So 1 by x into dx, we all know it is ln x. Then I substitute the upper limit and lower limits. Then I simplified, written in a simple form. Okay. Yes, is this fine? Shall we take up another example? Yeah, I will just give you one more example, which is similar to this one. So find the Hilbert transform of sinc function. Find the, hope is it clear now? The rectangular pulse. So next example is find the Hilbert transform of find the Hilbert transform of sinc function. Find Hilbert transform of sinc function. Yeah, you all know how do we define sinc function? Yes, anyone can say how do we define a sinc function? Yes, the sinc function. Sinc of t will be equal to what I can write? Sine pi t. Okay, sine pi t divided by pi t. Divided by pi t. So this is the definition of sinc function. Okay, sine pi t divided by pi t. Yeah, how do we solve this? Yes, Naurin, you can unmute. Yeah. Yeah, how do we go about this? Because people are not aware of what is a sinc function. Then see, very basic thing, no, rectangular function, it's Fourier transform into a sinc function, and vice versa also. If the sinc function in time domain, its Fourier transform will be a rectangular function. Why you are not aware of this? These are all the very basic signals which you might have come across in your lower semester. Huh? Yes, as I said, sinc function, right? Sinc of t. Okay, its Fourier transform. Its Fourier transform will be what? Will be a rectangular function. Okay, RECT of f, I can say. A rectangular function. And okay, I just give a hint, just try to solve it. So I know in frequency domain, right, G cap of f, that is Fourier transform of the Hilbert transform, will be equal to what I can write? Yes, G of f into Fourier transform of the Hilbert transform of the impulse response of the Hilbert transform, right? You have come across this equation or not?
Yes, sir.
So it is in frequency domain, right? So I said, what is the Fourier transform of a sinc function, sinc signal, right? It is a rectangular function, and I know how to express this rectangular function in frequency domain, right? And I know what is the Fourier transform of the impulse response of the Hilbert transform. So just multiply those two and try to simplify and see. Hope getting what I am saying. See, my G of f is what? Rectangular function, okay? My G of f, G of f is my rectangular function. RECT of f I can write. So how do I write that one? This rectangular function. Right, so this will be f, and yes, of course, its magnitude will be 1 over what interval? From 1 by 2 to minus 1 by 2. Okay, this is my G of f. What is my HST of f? Yes, you are all aware, no? What is HST of f? You can't say. How does it looks? HST of f, that is Fourier transform of the impulse response of the Hilbert transform. Yes, you people should say that. How does it looks? Fourier transform of the Hilbert transform of the impulse response of the Hilbert transform. See, HHT of f. HHT of f will be equal to what? Minus j sin m function, no? Minus j sin m of f. So how does it looks? Yes, it is j, right, for negative frequencies, and it is minus j for positive frequencies. Yes or no? Yes, have you come across this diagram or not? Yesterday I have discussed this one. Now what is your duty? You need to multiply these two, right? G of f into HHT of f. Then you will get the G cap of f. So is it possible to multiply and say what is the resulting signal you get? At least you can do that now, multiplication of these two signals. Yes, respond now. Can you multiply these two signals and say what will be G cap of f?
Yes, sir.
It's very, very simple. Yes, anyone can say, show, or is it possible to say what we can write? Multiplication of those two signals, G of f and HST of f.
So can you scroll?
Yeah. Just I don't know multiplication of these two. Right? Because how much time it takes just to multiply. See here minus 1 by 2 to 0, its value is 1, right? Here what is its value? HST of f, it is j. Right? So from minus 1 by 2 to 0, its value will be j, no? The value of g cap of f. Then from 0 to 1 by 2, the value of g of f is 1 and the value of HST of f is minus j. So minus j into 1 is minus j. Right? So from 0 to 1 by 2, we will get minus j. Yes or no? So simple task you are unable to say. I said the multiplication of those two. Multiplication of those two will be what? Your g cap of f, right? So what I said, your g cap of f will look like this. That is from 0 to minus 1 by 2. Sorry. Minus 1 by 2, right? Then next is 1 by 2. Okay. I said 0 to 1 by 2, the value of rectangular function is 1 and the value of HST of f is j. So what I can write? 1 into j is j, right? So I can draw like this. Yes or no? I think the rectangular pulse only of magnitude j. I can say it is like this. So its value is j. Then from 0 to 1 by 2, 0 to 1 by 2, the value of g of f is 1, but the value of HST of f is minus j. So 1 into minus j, you get minus j, right? So I can write a rectangular pulse, a pulse having a magnitude of minus j. This is what I am expecting. Yes, is this clear, this point? Yes, you all agree with me?
Sir.
Can I, yes, can I say it is g cap of f is like this?
Yes, sir.
So just I said in frequency domain, okay? I said what is g of f and what is HST of f. I wrote both the signals and I multiplied those two signals and I am saying this is my g cap of f. So this is a graphical representation. How do I say this in the mathematical form? Means I need to find out the g cap of t, na? Right? I need to take the inverse Fourier transform of this, na? So what is the inverse Fourier transform of this? See, to say g cap of t, right? G cap of t will be equal to what? Inverse Fourier transform of IFT of what? Yes or no? G cap of t is equal to inverse Fourier transform of G cap of f. So you all know what is the formula for finding the inverse Fourier transform. So which is equal to, I can write integral from minus infinity to infinity, right? I am writing the formula of inverse Fourier transform. That is G cap of f, right? Into e power j 2 pi ft, e power j 2 pi ft into df. This fine? Yes, students, we're all fine.
Yes, sir.
So just I wrote, see g cap of t. I want to get, no? I have to take the inverse Fourier transform of g cap of f. And this is the definition of the inverse Fourier transform of g cap of f, right? So now just substitute the value of g cap of f. I know what is g cap of f is. So will you be able to do that? So g cap of f is what? What is its value? From minus 1 by 2 to 0, its value is j, right? Then from 0 to 1 by 2, its value is minus j. Just substitute and do the integration. Yes? Yes, from minus 1 by 2 to 0. From minus 1 by 2 to 0. Right? From minus 1 by 2 to 0, the value of g cap of f is what? J. Isn't it? So j into remaining thing, that is e power j 2 pi ft into df I can write, right? Then plus, then from 0 to 1 by 2, 0 to 1 by 2, its value is what? Minus j. The value of g cap of f is minus j. So minus j into e power j 2 pi ft into df, okay? So I think further, I think you should be able to tell. I will not write. Otherwise, I will be keep writing from my side, and we will not be doing anything. I hope you know the basic integration, right? Yeah. What is the integration of e power x into dx? I think we should apply and say. Yes. What is the
Sir,
integration
can
of
you
e power
scroll
x?
down, sir?
Scroll down. No, just what I sorry. Yeah, I wrote this g cap of f. Then I said to find g at of t will be equal to inverse Fourier transform of g cap of f. Is this fine from this point? Or you want
Yes,
me
sir.
to scroll down still?
Enough, sir.
Enough, no? Then I wrote the definition of inverse Fourier transform of this one, right? So this is a formula. Integral from minus infinity g cap of f into e power j 2 pi f into df. So what I did, I just substituted the value of g cap of f. Okay, that is from minus 1 by 2 to 0, the value of g cap of f is what? It is j. J into e power j 2 pi f into df I wrote. Then from 0 to 1 by 2, its value is minus j. That is why I wrote minus j into e power j 2 pi f into df. So rest is yours. I think we should be able to simplify this. Just quickly, anyone can say, how do we simplify? What is the integration of e power x into dx? Yes, I will leave it to you people only. I will expect you to tell the answer in the next class. Okay?
Sir,
Huh.
sir, the whole term will be a constant, no, sir, because there's nothing with respect to f.
Huh. Hey, it is there, no man. E power j 2 pi f t into df. How it will be a constant?
I
F
got
is
this
there,
is like
no? Huh?
capital F. There you have written small f, sir. That's
Ah,
all.
you take small f only. Or you can take there capital F. Better. Okay. Yeah, it is. You take capital F only, man. So with respect to that, you can write, na?
Yes, sir.
Hope simplify, substitute the limits, and I think two more steps are there. I hope we will be able to do that. Just think. Yeah, by the way, any one of you can say what is e power j if I treat that as x, e power j x into dx.
E to the power jx by x.
Right. Yeah. So with respect to that, I think what I can write next step as better you do, otherwise you will not do anything. Okay. So any given hint, you people have code also e power jx into dx will be e power jx by x. So do that. So shoot the limits and tell me final answer. So in the meantime, you people can enter your USN in the chat box. I think others should also be proactive. I think people should not keep quiet. Only few people are saying yes, no, and they're answering. So active participation is the only motivation for a teacher. At least these few simple things should be able to do it by yourself very quickly. Yes, so hope everybody has written a reverse in the chat box. So I expect you to tell the answer in the next class, okay? I will ask randomly what is the answer. Yes, Deeksha, everybody has written a reverse hand?
Yes, sir.
Okay. Yes, Rushank.
Yes, sir.
You have written a reverse hand.
Yes, I've written.
Okay.